expensive to operate or comfortable and energy efficient, and the location of the windows can have a big part of that. Yeah.
Also, the number of windows that you have, make you feel exposed to this so many windows that they're glare or reflecting another building.
Yeah. So what we often talk about that is window to wall ratio. How many windows are there, or how much square area of window is there relative to the wall? And you can do that for each side of the wall. Any other thoughts?
The actual location of the house.
What about?
If it's in a shaded area, then we'll get all the sun.
Okay, so like the microclimate.
Or like the elevation of the.
Right. So would you think microclimate kind of covers what you're talking about? Yeah. Yes. I really like this one. So I'm going to lump that in together with occupant behavior. But yeah, in energy efficient housing, most energy efficient houses can be operated poorly. So I'll give you an example. Not with a house, but with a car. So a Prius, as you know, tells you, is the Toyota Prius, supposed to be very energy efficient. My dad got one of the earlier ones, and it tells you like what mileage you're getting, and he can get about 70 miles per gallon because he's just learned how to drive that thing. You know, it's kind of a funny that he's really learning. When his wife gets in the car, she gets about 30 miles per gallon. Same car, she doesn't care, she hasn't chosen to let it teach her. So it's the same with a house. You could get two identical houses, and we are going to talk about this and some of the ways you can help influence occupant behavior. So I'll just write occupants. But this is a really important thing. I saw it somewhere up here. Yes.
Another would be like interior design. Like you don't want to put certain rooms on certain sides of the house. You want occupant activities to kind of follow the sun. So like here in the Northeast, maybe the kitchen's on the eastern side of the house, so you don't have to necessarily crank the heat first thing in the morning when you're in the kitchen because the sun is already there. I get,
That's possible. I think what you'll find is that was a good solution with old, energy inefficient houses. And as we build better and better, if you've got an old house and you're dealing with what you've got, rearranging things might make sense. Newer ones, that's probably not going to be an issue. Yeah, but I think you're going to be surprised at how much that goes. But okay, so I don't know. This is a start, and I'm going to add this to a list that I got from last time I taught this course, and I'll put a survey up, and we'll get you guys to kind of rank these things and try to get a sense of coming in what you think are the kind of the relative value. All right. So how do we want to improve building energy efficiency? Well, we have essentially two approaches, technology and policy. Okay, so building elements, all these things, the windows, the materials, the insulation, all those things that we listed. And there are new technologies, right? So we can better thermostats. We can put in more efficient mechanical systems, all the things that heat and cool the buildings. And also more efficient management of the rest of the mostly electrical consuming things. We have to deal with new buildings, and my personal feeling is that really a new building should be a tremendously energy efficient building and not just a little bit better than an old building, but that's not the current way things are done mostly. And then we have old buildings, some of which are more efficient than new buildings already, but we have a lot of old buildings and we cannot just ignore them. We have way more, most of the buildings that will be around when you die have already been built. And you're younger than I am. And then the main thing is that we take a whole building system approach to any of these approaches, even if we're looking at a bunch of buildings. From a policy point of view, we have to figure out how do we finance these buildings that cost less to run, but cost more to build probably, or to repair. How do regulations, whether it's building codes, but also the plumbers union, how do these various essentially regulatory issues help or impede our attempt to build more and more efficient buildings. What sort of incentives are available? What sort of incentives work? Which ones don't work but cost a lot of money? And finally, how do we change the culture? This goes back to those. How do we change it so that people want these more energy efficient buildings and want to operate them that way? So we're going to kind of cover a lot of these things over the course. This is a critical slide. I don't know if other you've already checked the Moodle site, but I put up a PDF of these lecture slides, so you have to scribble all this down. But we're going to come back to this slide because this covers our building system, okay? It has, first of all, where is it, right? The environment, is it cold or hot? What's the environment like inside? And what's the personal environment of the individual whose comfort we're trying to provide? Then what's the building enclosure made out of? How does it survive this exterior environment? How does it relate to? How does it respond across the building enclosure? And what we're going to talk about is how building enclosures are built in layers. And that each layer plays a role in how the outside and the inside stay separate. Mechanical systems. So this is the way that we interact with that difference between the building enclosure and the inside. And so all of those things get inputs from people, right? We set our temperature set points. We decide when to turn something on or off. And we do that based on our physiology. Are we comfortable? And there's a big variation between, say, how I'm comfortable and how someone else might be comfortable. Our psychology. So different cultures, for example, have different comfort zones, different bands of comfort, different feelings about when you have guests over, what it's supposed to be like. And these things all matter. What it's like to be a comfortable person is a psychological thing. And then behavior. It's another thing to actually change behavior. So we're going to have to always keep these things in mind. And throughout, this is a critical slide. I don't know if other of you already checked the Moodle site, but I put up a PDF of these lecture slides, so you have to scribble all this down. But we're going to come back to this slide because this covers our building system, okay? It has, first of all, where is it, right? The environment. Is it cold or hot? What's the environment like inside? And what's the personal environment of the individual whose comfort we're trying to provide? Then what's the building enclosure made out of? How does it survive this exterior environment? How does it relate to? How does it respond across the building enclosure? And what we're going to talk about is how building enclosures are built in layers. And that each layer plays a role in how the outside and the inside stay separate. Mechanical systems. So this is the way that we interact with that difference between the building enclosure and the inside. And so all of those things get inputs from people, right? We set our temperature set points. We decide when to turn something on or off. And we do that based on our physiology. Are we comfortable? And there's a big variation between, say, how I'm comfortable and how someone else might be comfortable. Our psychology. So different cultures, for example, have different comfort zones, different bands of comfort, different feelings about when you have guests over, what it's supposed to be like. And these things all matter. What it's like to be a comfortable person is a psychological thing. And then behavior. It's another thing to actually change behavior. So we're going to have to always keep these things in mind. And throughout all of this, air movement, heat movement or heat transfer, and moisture movement and transfer are always going to play a role in every single interaction. So this is kind of this framework that we're going to use. So I want to really briefly kind of get out of the way the kind of the business stuff, of course. So in order to use. So I want to really briefly kind of get out of the way the kind of the business stuff, of course. So in order to cover the material that I think is important, I'm not going to be able to tell you all of it. You're going to have to read some of it. And that's good because, and this is a change in some ways from the last time I taught this where I talked a lot. I'm going to actually try to talk a little bit less and I'm going to have a lot more kind of in-class interactive exercises, workshops, discussions, etc. In order to have time for that, we're going to have to put more of it online. And we'll see how that goes. And that goes right down to this. Tell me how it goes. All right? This is an experiment for me, and I can change it, and I can take it. My feelings won't get hurt. So we're going to do discussions both in class, but we're also going to have some on Moodle. We're going to have small group work in class, but also outside of class. We are using Moodle as our main way to communicate outside of class. I've had in the past people very frustrated with the homework. It's not really that hard, but some people have found it difficult. It's supposed to make you think. It's okay to struggle with it. It's okay to ask me or Allison. Oh, and Allison, why don't you stand up? This is Allison. She's our TA, and the reason I'm glad she's the TA is because last year she was in the class in the graduate section, and it was always like, no, I'm not going to call her. I'm not going to call her. Oh, I know the answer. So now she knows the answer, and she's allowed to tell it to you. So, you know, come see us. It'll work. So that's what that is. So I think you're going to find that grading is really, really fair. I've put a lot of thought into this. There are enough different components that you can make stuff up in one component that seems to be falling short in another component. Within each component that has multiple iterations, so you have more than one assignment, more than one in-class work, more than one quiz, all of those, I'm going to drop the lowest score, okay? And then average the others. In addition to that, every single item, and every single item within those items, is going to be graded on a curve. And the purpose of the curve is to bring the bottom up so that you don't suffer too much of a penalty for having a bad day, and still allow the people who really put in some effort to shine. So, you know, that there is some distinction because people put in different levels of effort. But my theory is that this is a 50-50 exchange, right? It's 50% your responsibility to do the work, come to class, read the readings, right? All that stuff. But half of it is me trying to convey stuff to you, and I might do a bad job of it one day. Or it might work for some and not for others. And so a curve is a way to try to take myself out of it, essentially to control for being Ben. So that's why I do that. So most of this is self-explanatory. The final project, which is worth thinking about kind of during the class so that you give yourself enough time to really pick something that interests you. There's more than one choice, okay? You can do an energy performance analysis of a house and suggest strategies to improve it. And there's a lot you can do with a real house or a fictional house on that. You can make a proposal for an energy-saving innovation. In the past, some people have come up with some pretty interesting ideas. Do not break the laws of thermodynamics. All right? No perpetual motion machines. You can use a modeling tool, so I'm going to introduce a few modeling tools to predict the energy usage of a building you've designed. How many people are architecture majors? So you're probably designing buildings all the time. This might be an opportunity to take a building that you've already been working on and put it in a model and see how you could improve it, see how you could tweak it and change it to make it a better and better building from an energy point of view. So you can also research and critically report on a building product, material, or system that interests you and is supposed to be energy efficient. For instance, Allison knows all about SIPs, structural insulated panels systems. And that's a product that she knows about, is interested in, and has an energy efficiency claim about it. And so that's a project she is currently working on. You can also propose an alternative project. But you have to propose it to me, and I have to say, yeah, that's a good idea. And you have to give us enough time so that it can't be at the last minute, hey, this new idea. Like, no. Okay? And all of this is spelled out more in the syllabus.